Thank you. What we're looking at in the picture right there is the code hearings in Albuquerque we had back in May, and which are pretty interesting for severe geeks like myself. But when energy code compliance is not high on the list of things that are running through your mind. In fact, as a veteran of many years of project QC work, I can say with some confidence that code knowledge is not one of our profession's strong points. But you can also think of this knowledge as a way to protect your bigger project design goals, because if it's lodged in some corner of your brain, your design will naturally accommodate these concepts as it evolves, and this is all great for your client's confidence. Let's see. Do I have control of these slides, or do you? Oh, there we go. Energy codes are typically 200 or 300 pages, and we've just got an hour together. If I tried to go through all these details, you couldn't possibly remember them anyway. So what I want to do is take you on a quick road trip that'll go over the highlights that'll be most important to you as architects, starting over here in LA with an overview of some general principles, then stopping for a quick look at the residential code before we follow that general code organization along Route 66 through the building envelope, HVAC, lighting, and so forth, until we have a little chat about the future as we pull into Chicago. So hang on, we'll be moving fast. Along with the two major model codes, there are dozens of variations in force around the country. So first thing you should have on your checklist is to see whether you're using the correct code for whichever jurisdiction you're working in. And more specifically, whether you've got the code that will be in force next spring when you go to apply for your permit. It's amazing to me that there are firms that are so cheap they won't even invest in a set of codes for their staff for a new project. Here in Seattle, we're always getting architects from St. Louis or Kansas City or someplace looking stunned that we don't use the same code that they use back home. But these codes do all share a certain family resemblance, which makes this webinar even possible. The most basic division is between the residential and commercial code. And in the IECC, both codes are bound into the same book with the residential pages and their section numbers conveniently labeled R, and the commercial ones are labeled, can you guess, C. And ASHRAE puts them in two separate books, 90.1 for commercial and 90.2 for residential, except that as far as they've been able to find out, no one has ever used 90.2. They should have put all the multifamily into one or the other of those codes, but due to some long ago turf battle, the residential side of each standard governs low-rise multifamily, while the commercial side gets the 4 stories and higher multifamily. So here's the organization of the commercial IECC, but practically all the content you care about is in Chapter 4, except that lately they've broken out the existing building stuff into its own Chapter 5, which makes life easier for everybody. We'll get into more of this detail when we get to St. Louis. The residential side is organized in more or less the same way, but houses are comparatively really dumb simple as far as energy goes. And this code focuses heavily on envelope for residential. Look, what they call systems is all of 3 pages long versus 30 pages in the commercial code, and lighting uses up exactly 1 sentence. Now, very few codes, very few states use ASHRAE 90.1 as their primary code, but the IECC has a little exemption in the very beginning that lets you use 90.1 instead, if you use that whole code. So lots of projects use ASHRAE when they're doing energy modeling. ASHRAE puts the rules for additions and alterations at the beginning of each chapter instead of corralling it all into the Chapter 5 like IECC. Most architects think of codes about as fondly as they think of dental surgery, but perhaps in this case the code really is your friend. Probably most of you on this call work for firms that have signed the 2030 commitment, but only 3 or 4% of your projects from those firms are actually hitting that current target of 70% below average. Mostly because architects just can't talk their clients into it. But as soon as something's mandatory in the code, then everyone starts looking for the most economical way to do it rather than arguing about whether to do it in the first place. And the costs come down fast. Everywhere in the world, where high-performance buildings are being constructed at scale has a strong energy code that's making that happen. While all our voluntary programs put together have not majorly changed construction practice at all. So code is what is going to get us all there. Here's a famous red-blue map of the country, and of course, I'm from that dark blue state up in the upper left-hand corner. But we're an increasingly tribal nation, and for the conservative tribe, the energy code is a favorite whipping boy. Classic government interference in people's business, and unlike all the other codes, it has nothing to do with life safety. Plus, any kind of environmentalism is seen as a liberal cause and thus something to oppose. But liberals can go ahead and do efficiency to save the planet if they want, while conservatives can do it to save money, and that's where it's different from all the other environmental causes. Efficiency ends up producing consistently positive returns on investment with positive impacts for local economies. A lot of this philosophical divide runs along the urban versus rural lines. If any of you are ever frustrated trying to make progress in your cities, that's nothing compared to getting states or counties to change. But it actually seems to work out to let cities lead the charge. It's where the big design firms are headquartered and where the political support's strongest, and where most of our construction is happening anyway. And then the states and the rural areas can sit back and watch to see how it works out. Kind of like the caveman who waits a while to see what happens to the guy who just ate the bright red berries before they go there themselves. We don't need every place in the country to move at the same pace. Is there a way to move that little gizmo out of here? Yeah. Some new code provisions come from the latest technology, like solar panels, LED lighting, and others are just picked up from some other code, like California or New York or Copenhagen. Those are nice because somebody else has already done all the hard work for you in advance. There are new ideas, like a list of above code options that we'll talk about later. And finally, there are old ideas like air barrier testing, whose time has finally come. I showed Joe Stiebrook's first law of building science there: don't do stupid things, because at least half the building energy use is wasted. And a lot of that just comes from doing stupid things, only we don't notice that they're stupid because we've been doing them for so long they seem normal by now. Hello. I'm really proud of some code provisions I did regarding escalator energy use, but really how big a slice of the energy use pie belongs to escalators. It's better to focus on the really big wedges like HVAC and lighting and plug loads where you've got the opportunity. When somebody comes up with a new major for the plumbing code or the fire code, nobody asks them what the payback period is. That's only for the energy code. That graph on the bottom is Washington State's energy efficiency law that says our new buildings have to use 70% less energy in 2030 than they did in 2006. And you can see we're still on track here at the halfway point. But that graph in the upper right shows the range of cost for each energy source. And efficiency just always costs less than everything else. So bring it on as far as cost effectiveness. It's a good discipline for us to choose measures that pay for themselves in energy savings. And it shows a little respect for those people that didn't want these rules in the first place. At least it's an investment that will pay them back over time. Also, note that here in Seattle, where we have one of the most advanced codes in the country, we have some of the cheapest electric power and some of the highest construction labor rates in the country. And all these things still turn out to be cost effective. So wherever you live around the country, you'll probably be making out like bandits with these same ideas. You'd be getting back to the code organization. You generally have to choose between two basic compliance paths. Either just comply with every single rule in the book, which is how most residential and light commercial work is done, or you use the energy modeling path, which is typical for really large or complex buildings like hospitals and universities. You can either use the energy modeling formula in IECC or switch completely over to ASHRAE 90.1. Now, if you go for ASHRAE, you have your choice of two different modeling methods. The new method, affectionately known as Appendix G, is such an improvement that Washington State's on the verge of making it our only allowable modeling path. Note that back in the prescriptive path, there's an option to do trade-offs between different parts of the envelope, so that some parts can have better insulating value and others can have worse, but a lot of the country just uses ComCheck to do that function. You'd be surprised how many people have never peeked at the definition. The rule is that you can assume the standard dictionary definition of a word unless it's italicized in the text, in which case the word has a very specific meaning. We spent hours and hours at the recent code hearings arguing about changes to these definitions. Sometimes these proposals come from manufacturers trying to give their product lines some kind of advantage, and sometimes they're successful. So check out those definitions carefully every time you see an italicized word. Just a little disturbed because some graphics are coming up differently than I had planned here, but we'll just do it anyway. Chapter 3 has some miscellaneous basic information. Actually, right now, ASHRAE's map is slightly different from IECC's map, but last code cycle, ASHRAE had revised the map based on new research, but the voters rejected that change. So we're trying again this year, but who knows? There's some default U values you can use, but never use the window or skylight values for calculation because they're intentionally extremely conservative. It's only going to be useful if you're reusing windows from grandma's old farmhouse or something like that. Otherwise, use the NFRC tested values. Opaque doors, on the other hand, almost never have NFRC listings because they need to do a separate test for every single combination of door and frame and hardware. So use the default values, which, since usually the door area is a very small percentage of the envelope, the U value won't make much difference. Tell you what, I'm going to just switch out to what should have been the slide presentation that I had up, so that for the rest of the presentation, we'll have the correct one showing. What do you say? Slideshow from the beginning. So we go down like this. Yeah. See, we were going to be looking at a nice map there. So let's spend a little bit of time on residential. Remember that this side of the code is for single family, townhouse, and multifamily up to 3 stories, and it's overwhelmingly wood frame. Home builders are an independent bunch, and they especially dislike the energy code. So they've been vigorously and effectively working against energy progress. So at the IECC, we're only making about 2% progress a code cycle. Well, meanwhile, California, Washington State, DC, New York, and Massachusetts, others have been plowing on ahead, which is creating this huge gap between the leaders and the laggards. Probably all of you who do residential work are familiar with this requirement to post a certificate listing the R values and equipment efficiencies in the house. But I'm just going to bring it up because here's a golden opportunity for architects to brand this for your firm, and almost nobody ever does. The idea is that a visitor who likes this house could find out who the architect was just looking at the certificate, and a future owner could know right where to go when they're planning an addition or a remodel. So, and you could make it look a little bit more exciting than that. Residential code is really all about envelope, as I mentioned before, and the insulation naturally gets thicker the further north in the country you go. There's an R value table and a U value table, and the R value is just the value that's actually stamped on the insulation itself, while the U value is that insulating value of the whole sandwich, including your chipboard and your studs and plywood and everything. There's one subtlety with the roof insulation. If you use conventional trusses like you see on the bottom of those 2 diagrams, the insulation R value has to be either R38 or R49, depending on your climate zone. But if you use a raised heel truss like you see at the top diagram, so that the whole thickness of the insulation extends out all the way over the wall plate, you can reduce that down to R30 or 38 instead of 38 or 49. I once actually sat down to do the calculation to prove that this was completely absurd, but lo and behold, what I came up with was that this is right. To balance out that extra heat loss from that little strip of thinner insulation around the perimeter, you needed the rest of the insulation to be about 25% thicker overall. It's really not intuitively obvious, is it? The negative impact of some small area of thinner insulation is far greater than the positive impact of that same area of thicker insulation. And by the way, see that little diagram at the bottom? If you have a cathedral ceiling or a flat roof or something over a small portion of the house, like up to 20% of the roof, it can be just R30. So I guess that's so that it'll fit in a 2x10 rafter with a little ventilation. But there's one thing to know about all these roof diagrams you see here. They leak air like crazy. Each house needs a continuous air barrier all around that's sealed everywhere and pressure tested. But vented attics have so many transitions and penetrations that they're just about impossible to seal. So not only are you losing energy through those leaks, but the warm, moist air from inside is moving up in the winter and condensing or forming frost up on the sheathing above, which will eventually rain back down and start growing fungus here and there in your roof attic and matting down the insulation. So technically, it's much smarter to put rigid insulation above the sheathing or some other means of enclosing the attic space within your thermal envelope. Pretty much everything north of Atlanta or Vegas is supposed to leak less than 3 air changes per hour during the test, while in the south they let you get away with 5 air changes. And since I've spent so much time bragging about how cool we are in Washington State, I should mention that that's one of the only things in our code that's worse than the national standard. We still allow 5 air changes, but that's politics. So this has to be the most exciting slide in the deck, right? Ducts don't need insulation if they're inside of the conditioned space in the house, as long as they've been sealed and leak tested. But if you put them in the attic or the crawl space, then they need RA all around. Hot water pipes, on the other hand, do need insulation if they're 3/4 inch diameter or bigger, and this can sometimes lead to crowded stud spaces. So just note that as you're detailing things. And note that your required insulation can't be displaced by putting pipes or ducts in there. Okay, getting back to the commercial side of the code, we're going to follow that general organization of code starting with envelope, and there's a good reason that they put the envelope section at the beginning. Not only does that match the order of construction, but the envelope, and especially the walls, are going to sit there pretty much unchanged longer than anyone on this call will be alive. And it gives you much better long-term return on investment than any other feature. So if we're going to get to some kind of very low carbon future in the next few decades, really great building envelopes are going to be essential. And it's where you architects are already in the driver's seat. Whenever you want the air inside to feel different from the air outside, which in some parts of the country is about 49 weeks a year, a tight envelope means that your HVAC will not have to run as much. Now, if you don't want every single part of the envelope to comply with the U-value table, there's some built-in flexibility with the component performance approach. Using the formula in the code, you can multiply the area of each assembly type by its U-value and compare that with the results from doing the same thing using code minimum values for everything. A little confession here, I should note that the current formula in the code was developed and submitted by yours truly, and later one of my colleagues here pointed out an error in the formula, which is being fixed for the next code edition. But fortunately, nobody else seems to have noticed because most of the country just does this via ComCheck or some other software for the calculation. Architects have been in love with this concept of all glass buildings since Mies built that model 97 years ago. Just picture your oldest architecture professor for a moment, and then think his oldest architecture professor was already raving about all glass buildings way back then. I think the people who are still thinking this way today are suffering from just a stunning lack of creativity. And these all glass buildings could suddenly be seen as really boring and suburban looking as taste change. But who knows? If you're going prescriptive, the commercial code limits your glazing area to 30% of the exterior wall, and then lets you raise it to 40% through the use of daylight control. If enough in the daylight zone, which the way the code is currently written, almost every building does qualify. But meanwhile, after a lifetime of design, schools, hospitals, retail, mid-rise office, mid-rise residential, they all work beautifully with less than 30%. It's just only needed for high-rise office and high-rise residential. I guess it's the wow factor that sells those things. If you're still thinking that additional lighting power savings that you get by having really big windows will make up for that additional heating and cooling loads of the larger glass areas, think again. That's not correct. Skylights also have a maximum area in the code, but for many spaces, there's also a minimum area. If any of those spaces shown on the list are directly under a roof and bigger than 2,500 square feet with ceilings higher than 15 feet, then half of that floor area has to be in a top-lit daylight zone. It's not uncommon for a commercial building to lose 30% of its conditioned air through mysterious leaks, which is just enormous. So the code requires a continuous air barrier around the entire building envelope using some kinds of low leakage materials and assemblies that are listed there. The trouble is, practically every building material meets that leakage standard, and more importantly, it's not even the issue, because in real life, air doesn't leak through a sheet of drywall or plywood. It leaks through gaps where one trade leaves off and the next trade starts, or where somebody pokes a hole through the envelope. And the only way to find those gaps is to pressurize the whole building with blower doors. We've been doing this in Seattle for a decade now. Once everybody gets used to it, it's not a big deal, and we've cut our air leakage in half. It's got to be the most cost-effective energy savings in the whole code, and the bonus prize is that our stud cavities are much less likely to turn into corroding fungus museums with damp air leaking in and out. But apart from Washington State and New York City now, almost nobody requires air barrier testing. It's just insane. We'll know later this year whether a proposal to require this testing in IECC survived the final votes. I keep looking at this picture and wondering, like, where did they get those sheets of glass? Anyway, vestibules are required for buildings anywhere north of climate zone 2. So not in Miami or Houston, but definitely LA or Atlanta or anything north of there. They're required for entrances that are normally used for the public to come and go from the building. So this would include entries from the street or the parking garage, but not fire exits or mechanical room doors. However, the wording specifically says public. So that begs the question of a software company or a law enforcement agency where public isn't allowed inside. Do they need vestibules? I don't even know what the official answer to that question is, but in Washington State, we fixed that language. If your building has revolving doors, there are almost certainly some swing doors right next to them for accessibility and egress, and those swing doors also need vestibules. They're not required for individual apartment units or hotel rooms, or if you install an air curtain over the door, or if the door is serving a space smaller than 3,000 square feet, like a little coffee shop. I'd like to add that the vast majority of these code-required vestibules are architecturally really boring. Come on, architects. Here's your chance to do something really cool. I once saw a vestibule with sides made of glass cubes, each displaying one of the products made by the company inside. Or you could use colored or patterned glass or dramatic lighting or whatever, but here's something that's just begging to get some sophisticated design attention from you. Next section is HVAC systems. If we have any mechanical engineers on the webinar, they're going to start smirking right now, because here you've got an architect explaining mechanical engineering to other architects. It's like listening to Italians discussing American football. But I just want to mention a few things that architects should know about these engineering issues. First, though, you'd be surprised how many engineers are seriously misinformed about energy code requirements. Mechanical engineers, in my experience, often tend to be risk-averse and habit-bound, but not all of them are like that. Here in the Northwest, especially, we have several firms that are just not afraid to do really high-performing design work. And you've probably got some in your area as well. If you want to do really efficient buildings, you've got to have consultants that will push efficiency forward and not just tell you that it's impossible or that it's too expensive. What would you find, by the way, if you gave a quick little code awareness exam to each engineer as you interviewed them? You'd want to know also if they're just going to give you the same old system they've been designing since Grandpa started the firm back in '53. And here's one item I just love. Many engineers, most engineers, firmly believe there's a magic wall set 15 feet in from the windows, and that keeps air temperature at the perimeter separate from air temperature at the center of the building, and they actually install separate thermostats so that the heating and cooling can fight each other in the office all winter long. And this is normal practice all over North America. So for things like that, you want consultants that'll help you get out of those ruts. Not that I'm opinionated or anything about that. So here's a few basic energy strategies for mechanical systems. The first, of course, is that you select the most efficient system type for your building, which is odd because actually the code doesn't demand that. You can pick any system type and it's just compared against itself. Then you use controls that shut systems off completely when they're not needed at all, or turn them down when you don't need them running full bore. And I highlighted that last one because most of this section does exactly that. And finally, you capture and reuse waste energy where you can, like with heat recovery ventilators, like you see in the picture there. As architects, it does help to know some code basics so you can discuss them with your consultants. So I have just 2 slides here to show you a few highlights out of the mechanical section. There's a division of labor, by the way, between the codes. The mechanical code sets health and comfort standards, and the energy code says you have to deliver that health and comfort in an efficient manner. And this code, the energy code, protects your building's energy efficiency from that inevitable VE exercise where the contractor's ordered to cut everything out of the design that isn't absolutely required by law. The diagram in that last slide was an ERV, an energy recovery ventilator, and those systems can range from 50 to 85% efficient at extracting the warmth or the cool from your exhaust air and transferring it to your incoming fresh air. Size thresholds for this are based on cost effectiveness, so it would apply to fairly small systems for a 24-hour clinic in Minneapolis, but only to really huge systems for an office building in Montgomery. One little interior detail is that you need to choose convenient locations for those switches that let people who come in on nights and weekends override the automatic temperature setbacks. Here are a few highlights from that category called turn systems down when you don't need as much that I mentioned earlier. Demand control ventilation tracks how many people are in a room. So if they're rehearsing a school play and just have a dozen people in the auditorium, the ventilation will turn down to a minimum and then turn back up full bore as soon as all the kids come in for an assembly. It used to only apply to rooms like auditoriums, but now it applies to any room where the mechanical code schedules 25 people per 1,000 square feet. That's the mechanical code, not the building code that's driving that one. Kitchen exhaust controls is another big one, wherever you've got a commercial kitchen. Hotel rooms are designed so that the heating or AC will back off a few degrees when nobody's in the room for a while, and then back off some more when the room isn't rented at all. You can set this up so that the front desk can signal the room as soon as you sign that form, and it'll already be getting comfy by the time you unlock the door upstairs. And that last bullet is just a general strategy statement I made that is applied throughout this whole mechanical section, because HVAC systems almost never run at full capacity. So we need them to deliver optimal temperatures and fresh air in the most efficient manner at those part loads that they live at. Local energy codes, state energy codes, aren't allowed to require any higher efficiency than the federal standards. And for some kinds of water heating, the standards are lagging decades behind normal practice. So where the typical condensing boilers that you buy might be 92 or 95% efficient, the code is just asking for an 80 or 82% efficiency. I should also mention a new set of code requirements for how much water can be in that little section of pipe that runs between the circulating system and that lavatory faucet. And it effectively limits that branch to 2 feet long, meaning that the circulating pipe can't run up in the ceiling cavity anymore. And this is causing all kinds of problems. And I can't believe that I voted for it myself in those hearings before I really understood all the implications. So for the 2021 code, they've created a fix for it, but I think the fix is even more absurd. Code development can sometimes be a trial and error procedure, and sometimes the errors come out on top. What can you do? Moving on to lighting. I want this porch light at one of my favorite cafes to be our poster child. You can see it's a beautiful sunny day out, but that light just stays on as long as the indoor lights stay on, burning up energy for no good reason. And the lighting section starts with lighting controls, first interior and then exterior, and then it goes on to lighting power, first interior and then exterior. And the code requirements for lighting power are always lagging behind technology developments, which are happening really fast. But this list is very similar to what you just saw in the HVAC section, right? You start off with the most efficient lights, then you turn them off when nobody's around to appreciate them, or you turn them down when you don't need as much light. So look at the picture. What do you love about this? See, they have beautiful daylight from these wraparound windows, but the ceiling cove lights are still on at full power. If you set a light meter on the desk and blink the cove lights on and off, I don't think it would even register. Think back to that Stieber quote, don't do stupid things. You need occupancy sensors in most small enclosed rooms and also in any of those room types on the list. So if there hasn't been any movement in the room for a while, the lights will turn off. Note that occupancy sensors have a bad reputation in some place because some designers, but of course not any of you on the call here, put the sensors where they can't see all the occupants or where they respond to everyone walking down the hallway. Spaces like restrooms or office cubicles where you don't have a direct view of the occupants need a combination infrared and ultrasonic sensor. But in any case, be sure that whoever's laying out the sensors knows what they're doing, selecting and locating them with the same care that they show for selecting and locating the fixtures themselves. It's a big deal. The automatic time switch section starts out with this scary statement that they're required every place, but then it exempts all those spaces we just saw that got occupancy sensors, not to mention a number of other space types. So maybe the only space types impacted are corridors and big spaces like open office or whatever, but there's no sense burning those lights on all night and all weekend when nobody's around to appreciate them. So look at that. You need to have daylighting controls for the lights in your daylight zones. Actually, earlier code editions just required daylight zones to have separate switching and not automatic controls. So some of you are still running under those codes as if somebody was going to jump up and fiddle with the dimmer every time the sun goes behind a cloud. But notice in the box here that you need continuous dimming in these 4 space types. I hear that there are still lighting contractors who want to install stepped dimming, you know, that chunk things down 30% at a time. Those guys haven't evolved since last century. Note the list of exceptions here. And the first one is actually significant because 150 watts could exempt a large executive office with several LED fixtures. You know, those are using like anywhere from, I don't know, 12 to 26 watts per fixture. And so you can have a lot with 150 watts. So the lighting controls in those last 3 slides, the occupant sensors, automatic time switches, and daylight sensors are all included in an LLLC fixture, which has its own onboard occupancy and daylight sensors and wireless control so it can be adjusted from a remote console, which means that even though the fixture itself costs more, you don't have to do all that control wiring and commissioning. So the cost can sometimes balance out. Note that people are often away from their desks and work areas way more than they're actually at them. So if the lights turn down during those times, you get savings for lighting as well as for cooling the space. There's a couple of experimental setups here in the Seattle area that are getting 30 to 40% reduction in their lighting energy. Any kind of miscellaneous display or exit lighting needs to have separate switching from the general lighting, allowing those lights to be off after hours when people are just cleaning or stocking shelves. The list includes what used to be a minor category for grow lights, but that's become a huge user of electricity up and down the West Coast now for what's known as indoor horticulture. Note that one of these pictures is from a lighting supply website and the other is from the LA County Sheriff's Office. I think the difference must be whether they're paying taxes or not. But while a new Seattle office building has a site EUI around 40, one of these operations will have an EUI of 800. And not all growers are convinced that LED fixtures will allow them to grow that special variety that they're selling. And since they can't even get bank financing because of their federal drug laws, a lot of them simply can't afford the upfront cost, even when payback for using high efficacy lighting is generally less than a year, even at our rates. The lighting power allowance tables get a lot of debate each code cycle, but I can tell you that in Seattle, we have lower allowances than anywhere else, and nobody ever gets turned away from the permit desk for using too much lighting power. So yes, I suppose you still have to fill out the lighting power summary sheet. It's nothing to worry about. You can choose the simple building area chart. It has one allowance for the whole building, but most everybody uses the space-by-space method because it's a little more generous. Note that the space-by-space table has two lists, generic space types and others related to specific building types. So if you got any retail, note that there's an extra allowance for your retail display lighting. And not only that, but both ASHRAE and IECC have this huge loophole with a big allowance for any kind of decorative or accent lighting, whatever you interpret that to mean. Isn't that a lovely parking lot? You can see one car parked off in the distance, but otherwise all these thousands of watts are just shining on the damp pavement, keeping the coal industry in business. Note that there are three parts to your exterior power allowance. You get a basic allowance of several hundred watts to start, no matter what you're doing. Then you're allowed a certain amount for each square foot of parking, walkway, entry, sales area, and you can trade back and forth between those allowances. Beyond that, there's also some non-tradable allowances you get to use for things like facade lighting or gatehouses or cash machines. I wanted to at least mention a few concepts that are in the leading codes around the country, but not where most of you live. In Washington, we require that half the convenience outlets in several occupancies turn off by occupancy sensor or time switch, just like the lights do. And this is also in ASHRAE and in California code. We require every building to have a graphic display for the building engineer that tracks the gas and electric energy as well as several end uses. And Seattle requires a small solar array on commercial buildings, while California requires a substantial solar array for new houses. So these are all useful and important things, and they're going to be necessary for long-term progress to get to our goals, but not everybody obviously has the political will to tackle them just yet. If you're using the latest IECC, then you have to pick one above code option from this list of 8, but really everybody just picks the reduced lighting power because, like we mentioned, the lighting power allowances are way higher than anybody needs. So they can get this credit without having to change anything in their lighting design. If you have a new multi-tenant building, then each tenant space has to choose one of those options, except in that rare instance that the base building actually used renewable energy or one of the envelope options to get their credit. This list is a feature that ASHRAE 90.1 does not have. Since my state of Washington, as I mentioned, insists on being cooler than everybody else, we require not one, but 2 of the options. In the 2021 code, it looks like IECC will be changing from this just simple list to a points-based system so that the energy saving points are assigned based on your climate zone and your occupancy type. The energy modeling section is highly complex and technical, and not something to be undertaken by amateurs. The idea is that you can make some aspects of your building worse than code and balance that out with other parts that are performed better, and everything should end up being equal. However, you can tell by my monkey picture that I have a slightly less generous attitude towards modeling. Here's the famous Fred and Ginger building in Prague. There's a restaurant on the top with really cool dishes and glassware that's designed to complement the building shape. But anyhow, if Fred was designed prescriptively to code minimum and Ginger was designed using energy modeling, they should perform exactly the same, right? Which would be true if it weren't for these 4 factors, which we'll look at in turn now. The one I've already mentioned in relation to LED lighting, and you can see in the box how a good faith effort to write a lighting standard will still end up in force a decade after those initial measurements were taken, and by which time it's been left in the dust by progress. And for those states that are slow to adopt new codes, it'd be longer. Our friends in Oklahoma are still on the 2006 code, so for them, the time lag between the initial research and the final use of that code would be more like 20 years. Look, these are both big dogs. If you check with the British Corgi Fanciers website, that dog on the left is a monster because we're just comparing corgis with corgis, and the same goes for how we evaluate HVAC systems. We just compare each one to others of its own kind. Some help may be on the way with the new modeling path at ASHRAE, but that's going to take a while to filter out into the States. But the biggest reason is that the baseline case assumes that every single element of the building is the absolute worst allowable by code, whereas in the real world building, the lighting, the fan power, the boiler efficiency, and other systems use much less energy than allowed by code. Really, how many staircases have exactly 6 foot 8 inches of headroom? So modelers trade the performance of these systems that they were going to be installed anyway for a worse building envelope. Note also that the building envelope almost never changes, whereas the lighting and mechanical systems get replaced and upgraded on a regular basis. So by trading a better water heater for a worse window, you're locking in that inefficiency for just generations to come. By the way, have you ever wondered about those terms mandatory and prescriptive that are scattered around the code? You're not alone. The idea is that the mandatory means that you cannot trade away something's energy use in the modeling formula. You have to do it no matter what. Well, prescriptive means that you can trade it in the modeling formula. Got that? Anyway, we're getting rid of those terms for the next code edition and replacing it with a simple list of all those mandatory things at the beginning of the modeling section. I think I may have been the one who came up with that idea, but if not, let me know so I can get my story straight here. Anyway, for the very quick explanation of this system, the modeler creates 2 separate models, one that represents the proposed design, your actual proposed building, and the other that represents the standard reference design, which is that imaginary evil twin building in which every single thing is the worst allowable by code. So the art of energy modeling is to make your standard reference building look as bad as possible so that your proposed building looks good in comparison. Like if you're in a talent show, you always want to go on stage right after the worst act, right? So as long as the system stays in place, your architects with serious glass fixations can continue to design all glass buildings and no building official can stop you. Is this a great country or what? A big open question with modeling is which metric to use, and there are a lot of options there. Do you measure the carbon emissions or the energy used at the site or the energy burned at the power plant or the cost of the energy? And these end up being political decisions, and their values are shifting around as coal plants are retired and more solar and wind is coming online. Should you include the fugitive methane emissions for natural gas production? And if so, whose estimates of those emissions would you believe? And should you factor in the embodied carbon in your concrete and steel? Here's one interesting tidbit to consider with that. If you squeeze energy use hard enough, it drives the space heating and water heating towards electric heat pumps because they're so vastly more efficient than just burning gas to do those heating things. And that eliminates about 95% of the carbon emissions from buildings that are directly produced there anyway. Our existing building stock is huge in comparison with our new building production, but reducing energy use in existing buildings is a much harder nut to crack than improving new buildings. IECC has corralled all the existing building information into its own chapter, whereas ASHRAE puts those rules at the beginning of each one of those separate chapters. Note that even very new buildings are also existing buildings, our famous central library included. That the basic rules are that anything that was legal when it went up can pretty much stay there forever, while anything new that you do to an existing building has to meet current code. And this actually accounts for the fact that Seattle's energy use has been trending down for the last decade, even as we've been adding millions and millions of new square feet in this current boom. Because as our older buildings replace their old lighting and HVAC with new code compliant stuff, the energy savings have been dramatic. One factoid to note about additions is that either the addition itself has to comply with the code or the entire addition plus the existing building complies as one unit. So this addition to an historic building would be way over the glazing limit on its own, but considered with the whole building, it's no problem. Hang on, we're going to get to our place here in just a moment when we find it. So whenever you change from unheated to conditioned space, like turning an old warehouse into an experimental theater, you essentially have to make it a new building for the energy code. There are two exceptions, and you can thank me for those. Either your envelope can be 10% worse using the component performance approach with everything else being up to code, or you can do the energy modeling approach and have the overall EUI be 10% worse than otherwise allowable. The reasoning is, anytime you're doing a major repurposing and overhaul of a building, it really is a new building. In Seattle, we also make you bring those buildings up to current seismic and life safety codes following that same logic. The owners don't like it, that's for sure, but there will never be a more economical moment in the life of the building, and we can't wait another 50 years for the next opportunity to bring those buildings up to snuff. Same logic applies for change of occupancy or use, although the way IECC has it worded is seriously nasty. For one thing, they don't give you any standard to decide whether a daycare center uses more energy than a shoe store or an insurance office. But more than that, a strict application of this rule would mean that you'd never be able to move a pizza place into a retail storefront again without a total building upgrade. In Seattle, we said to solve that problem that this only applies when you convert factory, warehouse, or utility buildings into some other kind of an occupancy type. So, the future. I've proven to be a really bad prognosticator, but everybody else has been even worse as far as I can tell. The reality is nobody has any idea how things are going to go over this next decade. There are huge, heavy political forces and technological forces at play. One thing I wonder about is, what if we have some more horrific climate-related disasters? Would that start to change the prevailing mindset in the heartland? One thing is that ASHRAE and IECC can continue to develop new codes, but the more ambitious these codes get, the more resistance the states have towards adopting them. So that's when I say development doesn't guarantee adoption. ICC is guided by the votes of the building officials around the country, and a lot of them don't like change. ASHRAE is doing a better job moving ahead, but similar forces come into play there as well. One ICC committee is looking at creating some kind of above code language that cities wanting faster progress could conveniently adopt. So we'll see how that gets traction as it moves forward. People keep telling me that we'll eventually have to move away from our prescriptive code and towards a performance-based code. But there's no sign that that's happening anytime soon here. Denmark did this long ago. Their energy code for new construction is all of 6 pages long. They just tell you how much energy you're allowed to use, and you design a building that meets that target. And right now, they're pretty much close at that point where we're hoping to reach when we get to 2030. There's a lot of talk about requiring solar, like California is already doing for residential, but there are some interesting counter arguments that that's perhaps not the smartest idea out there. And once again, we'll have to see how that plays out. What are our big goals, and what is the best way of reaching it, and is putting a little array on top of every building the smart way to go? I tend to think that codes should start requiring things right away as soon as they're economically viable, but so that then the market forces will take over and drive the cost down further. But lots of other people think that nothing should go into the code until it's already well accepted by industry, which means something close to never. And the last point, for this slide at least, is this goal of net zero energy. It's net zero is easy for single-story buildings and impossible for high-rise buildings or buildings with heavy process loads. Should we really burden new building owners with generating all of their own electricity? And since buildings in the cold climates uses vastly more energy in the winter than in the summer, how do those net zero cheerleaders plan on storing all that summertime solar for use in January? As you might imagine, that's enough for a whole separate seminar. But what concerns me most is the potential for this political divide to exacerbate the economic divide. This is DOE's map showing the states with the strongest energy codes in darker green and the worst energy codes in darker orange. And it's overlaid with Urban Land Institute's 10 best and 10 worst places to invest in real estate. And you can see the unfortunate pattern there. So if the places that currently have the most vibrant economies continue to build more efficient buildings that operate more economically, while the laggard states keep building inefficient buildings that cost them more to run, is this going to actually continue making the situation even worse? I don't know. Every time the two sides of the political spectrum dig in their heels, we're in for a long struggle. Oh, right. Before we finish up here, New Buildings Institute wanted all of us to spread the word that, according to their calculations, we have to get all our buildings down to a site EUI of 22.6, which is 35 or 40% better than even new Seattle building right now, if we're to have any hope of achieving some kind of net zero nirvana. I estimated that number to even be a few points lower than 22.6, like 18.6. But not to worry, in the words of the great Mark Frankel, that which exists must be possible. So here's a new market rate apartment in Seattle that's operating at an EUI of 19. And on the right is the Corps of Engineers building here that's running at 24. And neither of them has solar on the roof, and they're both really nice buildings. So it's possible. The technology's all here, and it's not that expensive, actually. We just need the political will and an army of well-informed design professionals, like you, for instance, to make it happen. By the way, as much as it pains me to say energy efficiency is not our only value here, there are all these other culturally important things that we want to achieve with our buildings. However, I've rarely seen any conflict between high-performance buildings and human-centered buildings. When they're developed as a unified package, they just reinforce each other. So I recognize this is all really hard stuff, both applying the energy code as it is today and working towards what architects want it to be in the future. But please, let's work on it together, and together we'll make it happen. Thank you very much.
Okay, thank you, Dwayne. That was great. A great presentation. A lot of detail, a lot of information. Again, folks, we apologize for the very beginning. Sometimes IT is just out of our hands and we don't have control of it. We did record this webinar, and we will be posting it out there on our website within a week or so. The presentation is also available. We got that posted, thankfully, and you can go download that. It's a PDF. If you need the PowerPoint, you can send me an email and I'll get it to you. But it is posted as a PDF. And again, right now we're going to go ahead and take a lot of questions that did come in that are co-related and specific to the presentation that Dwayne gave today. So that'll be great. Dwayne, I'm going to go ahead and just read the questions out loud, and then you can answer them live. How's that sound to you?
Sounds good. Yep, let's go.
Oh, okay, I'm thumbing through them, and let me see what we got here.
It's
So, first question.
It's good to know that actually there are still people out there that are on our call.
Yeah, no, I do appreciate it. I know a lot of people jumped off, and I was trying my best to get what I could, and I'm not an IT expert, believe me, but I'm more of a code expert like Dwayne is, so I do apologize again. I wish I was an IT expert. But we got it going, and we have the presentation, and we have the recording, and there were a lot of people that did want to join in and listen to Dwayne because he's an awesome speaker. So the first question here, not really the first, but one of them. The 2015 IECC, in its section R402.2.1, if any of you are familiar with the codes, which we are, right? We know what that section is. Requires minimum insulation in the attic, either 100% at R30 or R38 for all the ceiling area. And this requires a heel framing, either stick or truss. Why rafters are I'm trying to read this. Why rafters are allowed to rest on top of plates in most municipalities. And you can say that if the permit is under the performance code, and then it never gets enforced. Any comments on that? So did I read that clear enough to you? So why rafters are allowed to rest on top plates in most municipalities, you can say if the permit is under the performance code, then it never gets enforced. I understand what they're trying to say there. You want to address that?
Well, the last part of the question was about enforcement, and as all of you practicing people know, that's varies incredibly from one jurisdiction to the next, and I do have some sympathy for our inspectors though, because typically it's just one person who is like given some incredibly short period of time to go racing around. And well, here in Seattle we consider it impolite to have buildings fall down in earthquakes or burn up in fires, and so prioritize that kind of work, and we work on accessibility, and then maybe they have a few minutes for energy, so they do the best they can with the really limited time they have. Rafters, I think that the code limits that using that R30 rafter thing for 20% of your total roof area or something like that. And so, yeah, if those rafters do extend out over the plates and the insulation comes right out there to the edge, that's kosher. That'll work.
Okay, great. This next one, definitely get a lot of questions on our help desk on this one. By the way, my name's Pam Cole. I'm not Lorena that you might see that's been typing in the back end. And I actually work on the codes program and actually manage the help desk and answer these questions that come. So, and again, you can address questions through our help desk if you have any questions after this webinar. And we're going to post the help desk and the URL that you need to take down. There's a URL to take down if you want a certificate for this training, or if you have an AIA and a number and you're an AIA member, we submit those to AIA. So I will say it out loud to you right now in case you're wondering and you want to jump off. The URL is energycodes.gov, and then it's / and it's evolution. I'm going to say it wrong now. I'm going to type it out so I don't say it wrong. But it's request a certificate. If not, send me an email. I'm easy, pam.cole@pnl.gov. That's an easy one, right? Or you can send an email to our help desk, and we will get that URL to you. Also, the URL is in the presentation that's out there on the website right now. So if you download the presentation, the last slide is listing that URL. We're going to take that off here shortly because we don't want people that are downloading that presentation that weren't listening today get credit, because we only give credit to live attendees. That's what we're allowed to do. So go ahead and download that presentation. You can get it right now, or I'm going to type it in here in a minute after he's done answering some questions, and you can take that down and write that down. Anyway, back to some of the questions here. This one, I hope Dwayne can answer this one. This is a doozy. A lot of times we get this. So in the 2018 IECC, address change of use. And this one says, for instance, if a church wants to move into an existing warehouse, change to an existing warehouse, what parts of that building are required to come into the energy code standards or need to comply?
So change of use from a church to a what?
This one says, for instance, a church wants to move into an existing warehouse. So what parts of that building are required to come up to the new energy code standards?
Okay, so it's almost certain that the warehouse was using dramatically less energy than the church will be using, and so that is pretty much treated as though it is a new building, and it's actually hitting a couple of things. One is that in the 18 code, 503.2 is the change in space conditioning, and 505 is the change of use. So that will be required to be, the first requirement is everything in the whole thing meets the energy code, the whole energy code. Now, that's not going to happen on the slab edge in a warehouse, right? So that's where we have those exceptions that you can either have the envelope be 10% worse and have everything else comply, or you can have you can do energy modeling and have the everything be use 10% more energy than you would otherwise use with modeling. But obviously, going from a warehouse to a church, you're not going to be reusing any of the mechanical systems or lighting, water heater, or anything that was in the building before. So that stuff is all going to be new anyhow and therefore meet current code. So you'd have to insulate the walls and the roof, and then perhaps use your 10% forgiveness there for the envelope to not insulate the slab edges.
Great, sounds good. What happens if a warehouse is historic and it has a change in use, or it changes to a museum?
Well, no, it's a really good question. Historic buildings have their own special requirement, and it used to be that it just said if you're a historic building, you go completely scot-free. That's not the case any longer. And so what it says now is that you don't have to do anything that would threaten, degrade, or destroy the historic form, fabric, or function of the building. And so typically, like a warehouse will have a flat roof, and no one cares what the roof looks like, so you can insulate the roof. You can probably the inside of the walls of the warehouse are nothing special. I mean, like those. But in any case, you have to do everything in the code unless your historic preservation officer says, like they always say about windows, don't touch those windows. That's like critical. And what we do here in Seattle is we simply consider, when they say don't touch the windows, we consider those old single pane wood windows to be what is code minimum for that part of the building.
Okay. To jump back on the attic, so then we can be done with attics, and we'll move on to some other ones. It's a good question. On a residential attic, the slide that you had, it says you can go down to a lower R value if the full height of the insulation covers that top plate. And meaning you will likely need a raised hill truss to get R30 or R38 as required. Is that correct?
That's correct. And
Okay.
it does interesting things to the way your eave looks. So you have to be careful about designing that. But yes, you can. That allows you to use that lower insulation value if you just run it all the way out to the edge.
Okay. A lighting question. Is there any thoughts about adding wattage threshold for occupancy sensors, similar to the daylighting threshold of 150 watts? And then also another one, the same person is have two in here. Adding an occupancy sensor for a room with a 10-watt LED seems excessive. Let me see. I'm getting all that.
Yeah. No, I get the question, and no, occupancy sensors are really inexpensive, and the fact is that there are many mechanical rooms and closets and other places where that sit empty the vast majority of the time, and if they don't have such a sensor, the light is it just stays on because people don't think to turn them off, and they can stay there. They can stay on so long that the light actually burns out, and when you actually do need that room, there's no light available. So no, we gave a pass for daylight sensors for small spaces that are along the windows, but not for occupancy sensors, and I don't think there's ever been a proposal to do such a change.
Okay. I'm scrolling down here to a couple more. On the commercial side, how is the, oh well, this is a software question. I think I'll answer that one personally on that one. Review and identify new daylighting requirements. I know you talked a little bit about that, but can you go into a little bit more detail, or we probably don't have some time for meeting? It's up to you.
So what's the question exactly?
Let me change to another one because that one might take a little bit more time. When there is a limit on the window-to-wall ratio when using the component performance, is there a limit when using the component performance alternative? Is there a limit on the window-to-wall ratio?
Yeah, you have either the 30 or the 40%, depending on what you qualify for, and since the current rule for buildings over 3 stories is that it only has to be 25% of the floor area has to be in a daylight zone. That's practically every building that has windows at all, and so that puts you up to 40%, and that would be the starting point for your component performance calculation. Remember that I mentioned that there was an error in that I put in that formula for the calculation, and so you might want to check. I think you can see the current fix that's out at IECC for the proposed code changes.
Now that comment came in, or a question came in about, is there somewhere where you can see the changes from one code to another that appear, in each version? And yes, there is. ICC does publish a document that comes out. You know, it lags out because they are going through all of the new changes. And they do post a document out there. It's not free, but it goes through all the code changes. And in some respects, the last one for 2018 was great because it showed some of the comments, how that new provision came into play, and then that new provision. So that might be something you want to go take a look at when they have that next one ready. Okay,
well,
so next question.
Well, there's one other thing to note on that, and that's that in the margin of the code on the side of the page are these dark black vertical bars, and those indicate something changed in that spot. So it gives you a quick way to highlight something.
Yeah, so if you're purchasing like the 2018, it'll have bars that shows you change from the previous code. And when the next code comes out, it'll be changes from the 2018 to the 2021. So right. You can look at it that way, but it doesn't tell you what the change is. I mean, the old change was, or the old requirement. You'd have to go back and have both books. But this new book that came out is pretty nice. So anyway, and if someone needs a link, I can go find it for you. And you can send me an email. Are there any exceptions that you are aware of for parking garages in regards to the thermal envelope requirements? My interpretation is that any support, I'm trying to scroll this over, any support in support spaces being, and it stopped. I didn't get the whole question. It's not in here. So how about you just go off the parking? Are there any changes in parking garages in regards to thermal envelope requirements? Let's go off that because it doesn't have, it jumped off.
Remember that the thermal envelope section only applies to buildings that have some sort of thermal load. And so unless your parking garage is conditioned space, it's a low energy building and it's exempt from the requirements of the building envelope entirely.
Oh, his interpretation, I hear it is. And his interpretation is that any support spaces being either heated or cooled needs to meet the requirements. It might be maybe thinking of semi-heated spaces too.
Right. Well, we don't really have semi-heated space in the IECC. We have something, yeah, something like that in ASHRAE. But in this case, yeah, we would require, if you have an office, which happens sometimes in a really big commercial garage or a lunchroom for workers or something like that, that would have to have its whole thermal envelope wrapped around and insulated.
Okay. Yeah, right. It has to be a conditioned space. So, next question here: are there any exceptions that you are aware of for? Oh, hold on. I'm jumping around. I apologize. The building thermal envelope thermal calculation. Can we use U or R value interchangeably?
No. If you're doing a calculation, it has to be by U values, and you can prove this to yourself. If you try to add and subtract R values, it becomes absurd. So the only way to do any kind of trade-off or calculation is to use the U value of each assembly.
Okay. We are staying on a little longer than we had originally planned for this, but we do have a lot of folks that are online that are staying on listening. So I guess they're wanting a lot of more information. But we are going to have to take a couple more questions and then close off since we did promise a certain time frame, even though we started a little late. So let me take a look and see if there's any more great questions that came in. Again, send your questions in to the help desk if you didn't get your question answered. Here's one. How should you enter insulation, and I'm guessing this is a software, insulation on walls if the insulation is only from the ceiling to 10 feet above the finished floor in a warehouse? So how should you enter the insulation on walls if the insulation is only from the ceiling to 10 feet above the finished floor in a warehouse?
I have no idea why anyone would do. I guess what they're talking about is that they want to have an abuse-resistant lower portion in the warehouse, so that the forklift won't bash it up or something. But if I'm presuming then that the warehouse is a conditioned space, it's not cold in the winter, and then you'd have to do some kind of energy modeling or trade-off, and it would never work. It's just amazing when you try to trade U values for uninsulated sections, even if they're very small, by beefing up insulation elsewhere. So if it's conditioned space, then you've got to bring your insulation all the way down and to wrap this building. So sometimes people end up having to build a sandwich type arrangement with the main CMU on the outside, and then a sandwich of insulation, and then a thinner CMU on the interior face to be the abuse resistant face there.
Okay. Another question. Let's look at our last one, and then we'll sum it up here. This would apply to conditioned space. So how would you apply like an IT room or an elevator machine room to the code?
Well, an IT room and an elevator machine room each are typically within a conditioned building. I'm presuming they're not talking about something that's just entirely by itself, and so there are rules for cooling in your IT room or the machine room, and I can't think of anything in particular that's important to architects on how those would have to be treated any differently. They get more cooling in there, and in some aspects of the code, if it's new construction, they also are subject to economizer rules. Sorry if I can't be more explicit on that. It's a big topic.
Yeah.
I just asked.
Well, one question came in and said, can you address Appendix G in a little more detail? And I think, no, I don't think so. None of this presentation. That takes a little bit longer to do, so we didn't address that one, so I do apologize. But you can send that in, and we can answer it, to the help desk, or send it off to Dwayne, and maybe he can provide some more information on that one. Well, I thank everyone for listening in today on this presentation. Dwayne's an excellent speaker, as I said. A lot of information to go over. If you have any questions, submit them to our help desk. Our help desk is out on energycodes.gov, an electronic form. On the main page, you'll see the URL to it. Again, I've sent out the URL to request a certificate to receive AIA credit. We also offer ICC credit. We are an ICC provider. And then if you have a professional organization that you need to submit your credit to, such as an ASHRAE members and so forth, you can do it through the certificate. And if you need to, send me an email, and I'll get the information to you, and we'll get that certificate out to you. This has been recorded, and we will post the recording out on the website under the training. And then we offer other training, so keep an eye out under the energycodes.gov/training website for upcoming webinars that will be taking place. Again, thanks for your patience, and all of you have a great day. Thank you. Now you can all disconnect.